Now we are ready to deploy applications on our EKS cluster. So it is the same as how we deploy applications on Kubernetes cluster using kubectl tool, just like normal how you do it on premises. So for this, you need a kubectl command line tool to communicate with our EKS cluster from your laptop. So we are going to deploy some sample application. It's a PHP application to run and deploy on our application, so that, and we are going to define resources for that application, so that once it reaches that maximum resources defined for that particular application, so it cannot process the request, so it cannot accept the more requests after that, so that our horizontal pod scaler jumps in and it will create new replica for that particular pod. Still we haven't deployed horizontal pod scaler now. First we deploy some sample application, and later we deploy horizontal pod scaler, and we'll see how it works. And I have given information how we can deploy some sample application. So this is the command. Using this command, you can extract some sample PHP application from this particular GitHub repository. Not GitHub, some Docker registry. It's a HPA example, that is the image name. By running this command, we are extracting this image and deploying on our EKS cluster. So PHP Apache deployment is created. Now you can run the command kubectl get pods, and you will see that there is a PHP Apache pod is created for us. So it shows the status container creating, and if you run again, it will show you maybe it has been created as running successfully. Now we have to limit the resources on our application, so that we can test horizontal pod scaler, how it can scale up and scale down the application based on the request and CPU utilization. So we are going to modify the existing application by providing some resource limits. By running this command, which I have been provided on my GitHub repository, and we are applying the patch for existing application. If you run kubectl get pods, you can see that the old application will be terminated, the new patch will be applied. That you see the old old pod was terminating, and the new one will be running. So now we have the running application, which will be tested by ingesting more load on this application, but CPU limit we have given just 200 microns. So the application cannot handle more than 200 microns of process. So now we need to deploy horizontal pods autoscaler. So actually what horizontal pod autoscaler does, actually it automatically scales up the number of pods in a replicator controller deployment and replica sets based on CPU utilization. So it keeps monitoring our pods and how they are utilizing the CPU resources. So it keeps checking. So this is implemented as Kubernetes API resource and a controller. The resource determines the behavior of the controller, periodically adjusts the number of replicas by observing CPU utilization to the target specified by the user. So this way, horizontal pod autoscaler ensures that if there is more load on the existing pod and it cannot service the request that is coming inside the cluster, so horizontal pod autoscaler jumps in and it will create the required new pods. But there is some limitations also we can define on horizontal pod autoscaler, how many maximum pods it can create. So we don't want to create 100 pods because it will increase the bill service charges, and also we don't want that. So even we can limit the how many pods it can create. And one more thing, we need metric server. Actually, a Kubernetes cluster doesn't have inbuilt metric server, so we need to deploy metric server also, so that Horizontal Pod Autoscaler uses the metric server and gets the metrics from all the pods running on Kubernetes cluster. I have the metric server application Kubernetes object as a YAML file in my project. I'm going to deploy this on Kubernetes cluster. So this is the metric server YAML files. I'm going to deploy this all YAML files. So for this you need to run kubectl apply -f dot. So this command ensures that all the YAML files are deployed so that our metric server is up and running. So you can see these statements. So all the required metric server components are deployed, and you can run command and can check all running properly, and you also get all command as well. Better I can clear it and can run then you can see clearly what and all running on our Kubernetes cluster. You can see that PHP pod is running, and Kubernetes service is running, and deployment of PHP Apache and replica set, because this is the older one which was already terminated, but still it shows as 0 and current ready, so nothing, so just ignore it. Now we are going to deploy Horizontal Pod Autoscaler. We already seen that what actually Horizontal Pod Autoscaler does, and we are going to deploy it. If you go to my GitHub repository, I have given some commands. Using this command, we can create Horizontal Pod Autoscaler. So in this command, we are going to define, like, this is autoscale, this is autoscale. This is the command which will ensure that HPA will deployed. On PHP Apache, this is the name we are going to give for our Horizontal Pod Autoscaler, and CPU %20. So we are giving the resource limits. So if it crosses more than CPU % as 20, if it is crosses the CPU % of 20%, then it will cross the limit, so that our HPA will jumps in and it will create the new pods for us. So the minimum pod we are giving it as a 1 pod should be running always, and maximum 20. So it can create maximum 20 pods for us, not more than that. And also we can deploy HPA in a different way as well, that is using a YAML file. I have given a YAML file in our GitHub repository, you can check it. So the content of the YAML file will be look like this. So the same details that we have here. Of course, here I am given maximum replicas 20, maybe 1 replica. Yeah. So you can see this file, and it will be the same as that, so that you can use this file as well, but just running like the same way we can deploy this, like, you know, setting HP and kubectl apply. So by running, but I'm going to use this command to deploy Horizontal Autoscaler in our cluster. Copy this. Let's go to, let me open another command prompt so that so it has been created. If you run get all again, it will show you that our Horizontal Autoscaler is deployed, and it is getting the metrics information from our PHP. Actually, now it shows targets as unknown, but it will be showing because exactly. Let me see. It should show as 0%. Yeah, the maximum is 20%. So if any pod crosses 20% of CPU utilization, it will try to create the new pod. So now max pods is given 20 and replicas 100. So it can create only 20 maximum pods. Currently we have one pod is running. Now we are going to put more load on our PHP application so that we can see that how the percentage of CPU utilization is increasing, and once it crosses more than 20%, our horizontal pod autoscaler jumps in and it will create more pods for us, depends upon CPU utilization. Yeah, let minimize this. Sorry. Here I'm going to run this command. So it will create another it's a load generator tool. Basically it's a shell scripting so that we can put more load on this application, PHP application. So we need to run this command as well to generate a more request and sending it to PHP application. And sorry, we forgot to create a service for our PHP application, because otherwise you cannot access using this command. So before that we need to create the service. Let's run this command. It will ensure that service is created for a PHP app. So I will show you that. Now you see that earlier you don't see the service for our PHP app. Now after deploying a service, you can see that service has been created for our PHP sample application, so that we can hit this PHP URL and you can put more requests on it. See, the now service is available. Earlier it was only Kubernetes service. Now you can see the Apache service as well, which is running on port 80. Now we are going to call that application via port 80, and it will create more load on the application. We are going to put more request on it. What is this? Yeah. So it will keep sending more requests to the PHP application, and we can monitor that it increases. It is getting more CPU usage. Will be increasing on application. Let's clear it. kubectl get all by putting watch, maybe get pods, better get all. We'll see that percentage of CPU utilization, and it will still it is normal. See 482% now. So, and also it is created another 3 new pods for us. So it's creating more. So 482% is the, so it's already crossed the 20% of CPU maximum, and the new replicas has been created. Now it is 4 new cores has been created. Maximum it can create 20 only. Meanwhile, we want to test Cluster Autoscaler as well. See, once 20 pods has been done here, it is creating more load on it, but of more than 20 pods it cannot create. So in that case, we want to Cluster Autoscaler jumps in and we want to create a new node for us so that it can deploy new pods on the new node. So how we can deploy Cluster Autoscaler? So I already have the script to deploy Cluster Autoscaler on my project. So just I'm going to deploy Cluster Autoscaler as well. For this, we need to get into Cluster Autoscaler method and just run kubectl apply -f and -f. So it will ensure that Cluster Autoscaler has been deployed, and we can see the statement. Yeah, it has been created. So actually, when you run kubectl get nodes, only 2 nodes are available. Now we are creating more load on PHP pods, 1 node, and it creates more load. So our cluster doesn't have enough nodes to deploy new pods. So what it will happen, Cluster Autoscaler jumps in and it will create a new node for us. So now it has been reached a maximum 20 replicas, and it has been created 20 pods for us. So you can see that there will be more pending status of pods. So whenever Cluster Autoscaler sees this pending status, it will try to understand that there are no enough nodes that can serve the new pods. So there is no new nodes that can handle the more pods. So Cluster Autoscaler jumps in there and create the new node for us, and it will take some time to create the new node, and you can monitor that. Let me open another new window, then we can check nodes. Now currently we have only 2 nodes. Let's wait. It will create the let's wait for to see another worker node for us. Before that, I want to show you what and all has been created by Terraform for us on EKS cluster. Just EC2 dashboard, and you can see, of course, there are 5 security groups has been created for us. Default EKS cluster Terraform, this and all we have been defined our Terraform script. So as per the Terraform script, the required security groups have been created. And also you can see that auto-scaling groups. So we have defined auto-scaling groups like instances. Minimum instances should be 2, desired 2, yeah, and minimum 2, and maximum is 5. That as we have shown you earlier. And availability zones, default cooldown. So cooldown is nothing but like, once the new worker nodes has been created, and whenever there is no much load on the node, all the 3 nodes, so Autoscaler must scale down the new node or one of the nodes. So the cooldown period, that means, so it will take 300 seconds to cool down another node. And health check, yeah, it checks every 300 seconds once to collect the metrics how the cluster is running. So the health check metrics will be fetched every 300 seconds once. The default cooldown period is 300 seconds. Of course, we can customize it by editing this, by clicking this button, and we can edit and we can change it. But we don't want to edit this. So the auto scaling group has been created as we need. That's what you can see here. And even you can see EKS cluster information as well. Elastic Kubernetes service. So So this is the name that we have given for our EKS cluster name, and you click on it and you can see that complete information, Kubernetes, which Kubernetes version it is currently on AWS platform version, and API server endpoint. So this is the Kubernetes API service URL and subnets details and the virtual private cloud details. So all this information is available to review. Amazon ECS, Elastic Container Service. I don't think so. There is something that is relevant to it. Yep. So that's what it has been created as per our Terraform script that we have defined. 2 volumes has been created. Now there is no enough space on existing worker node, so Cluster Autoscaler should jumps in and should create the new worker node, but still actually it is taking too much time to create another node, but I don't know. I have to look into that, but I will show you how Horizontal Pod Autoscalers scale down the pods when there is no much more load on the PHP application. So further I'm going to stop the sending request to the PHP applications by stopping the script. Just press the Ctrl C. So now it is going to stop sending requests. So now you can see that now you can see replicas actually currently 20 replicas. And it is going to scale down all the pods because there is no much load on application, and CPU utilization also will become less. Now get all. So there is no request coming into PHP application, and obviously it should reduce the number of pods. See, now the CPU utilization became 11%. It is less than maximum that we have defined as 20%. So obviously it should reduce the replicas. So by running kubectl get all command, it will fetch all the information from our Kubernetes cluster. Now you can see that the increase in pod replicas. As per current configuration, the horizontal pod scaler can create maximum 20 pods. Later it cannot create on existing worker nodes. In this situation, Cluster Autoscaler observes what is happening with each and every node. So if any node doesn't have enough capacity to host the newly created pods, it will try to create another node for these new replicas. We can check. Just run kubectl get nodes on namespace cube system. See, it has been created another node, and you can see the same details on AWS console as well. You can see that one more new node has come up. Earlier it was only two nodes, two EC2 instances. You forget about the below one. Just look at this. So there are three instances completely running, and new one is still initializing. And if you run the kubectl get all command, and you can see that it has already reached 20 ports. That's the reason Cluster Autoscaler came in, and it has created another node for us. Now I'm going to reduce the load on our PHP application by stopping this script. Obviously the memory usage will come down, and pods also will be killed one by one, and later Cluster Autoscaler also will remove the excess node, because there is no much pods are creating, so that it will destroy the newly created node. See, now all the three nodes are ready, and it can create up to maximum 5 new nodes. Yeah, now we have seen that how Cluster Autoscale can scale up the new nodes, and at the same time we have seen also how Horizontal Pod Autoscaler can increase the replicas based on the load or CPU utilization on pod level. So this is the best example how we can automate the scaling up of and scaling down of the pods and as well as nodes. I'm going to stop the script. You can see that now the load on PHP application server, PHP application is going to be reduced. So it's coming down 25% now. Whenever it comes down to below 20, obviously Horizontal Pod Autoscaler jumps in and look into the CPU utilization, and it will try to kill the pods, because there is no much load on the application, so only one pod is enough to handle the current requests. So whenever it comes to below 20%, so it should reduce the number of replicas. Now there is no much load, still it is showing 25% because already some request has been sent to the application. So the newly created instances are still processing those requests. Yeah, it has taken a little bit extra time, but now you can see that there are no 20 pods are running. There is only one pod is running for PHP application, and you can see the number of replicas reduced to only one. Yeah, so obviously even now Cluster Autoscaler will jump in. It should jump in and look at the current nodes and current capacity and resources utilization. So obviously if it is less utilization is happening on existing nodes, it will kill the newly created node. That's it, guys. So this is the best example how we can use Horizontal Pod Autoscaler to scale down and scale up the pods, and how we can scale down and scale up the worker nodes on EKS cluster. Thanks for watching this video.